Hello, this is section 5.5 properties of logarithm. Okay, so when you have a logarithm rules, if the base is any number, right, but can be of course negative or 1. So as long as it's not 1 and then the positive number, and then next to the log 1 is always equal to 0, and then same a and a is equal to 1. And then when you have a addition of the two log with the same base, and you can just multiply the number next to the log. Quotient rule is when you're subtracting the two log with the same base, and the number next to the log, you can divide it. And power rule, if there's a power with the numbers, their power always can be a factors of the log. So we can just, if you have a log of 10a, same as log of 10 plus log of a, and x over 5 becomes log of x, subtract the log of 5. And log of x cubed, it will be same as 3 times log of x. And either ways, so you can expand it or you can combine it. All right, so the next problem is use a calculator to evaluate each pair of expression, and then state which property logarithm, so their calculator illustrate, okay? So which is log of 7 plus log of 4, which is, if you separate it, calculate it, you'll say log of 7 plus log of 4, and then it shows as around the 1.447, and then log of 28, if you using the calculator, and then it'll same as 1.447 around there, okay? So it's the same, but which means this is we call the product rule, because you have an addition becomes a product. And then this is the quotient, the subtraction. So ln 25 minus ln 5 is ln 25. Subtract ln 5 is about 1.609. ln 5 also by itself, we got 1.609. So this one we call the quotient rule. When you divide 25 by 5 is 5. And then also log with the 6 cube, which is log of 6 and then power of cube, which is 2.334. And then 3 times log of 6 is, if you do that, 3 times log of 6 is like 2.3342. So this we call the power rule. Okay, all right, let's do the next page. Now we're gonna use the power of the logarithmic rules to expand the expression, okay? So which is, these are the products, you can say as ln k ln k plus ln z, and this is the quotient, so you can say log, but you keep the base 2, x minus log of base 2z, and this is the quotient, and also I have to use the power, but let's apply the quotient rule first, okay? And the quotient rules, okay? So log of square root of x cubed, subtract log of k, and also log of square root of x cubed, same as x to the 3 over 2 power. And then 3 over 2, you can pull it out as a factor of log of x minus log of k. All right, I'm going to expand more expressions. So in here, it is a base of 2 of 4 and plus log of base 2 of y cubed. And then the log of 4, 4 is the same as 2 square. And then you can pull out the 3 as a factor of the log base 2 of y. And then you can factor the 2 as a log 2 of 2 plus 3 log of 2y, which is log of base 2 of 2 is becomes 1. So it's same as 2 plus 3 log base 2 of y. All right, same thing as this one too, okay? But there are 2 factors at the top, 2 factors at the bottom, which means you're going to have a 2 positive ln, and you're going to have a 2 negative ln. So 1 ln x plus ln y cubed, subtract ln w minus ln square root of z. And then ln x, I don't think you can any simplify, but 3 you can factor it out. ln w is the same, but z is the same as 1/2 power. So now you can say ln x plus 3 ln y minus ln w minus ln half of ln z. So that's all. For the last one, we have a quotient. So log of square root of 2x plus 1. Subtract log of x plus 2 squared. And then I need to find the power. So 2x plus 1 is square root, which is same as half power. I can pull out the 2 log of. Make sure that you put the parentheses. And then finally, you can pull out the 1/2 as a log of 2x plus 1 and minus 2 times log of x plus 2. So that's all. And then you can expand anymore. All right, let's go to the next page. And then example 4, and write as a logarithm as a single expression. So since this is a sum, so I can make that as a product. So ln of 4e squared times 3 to the e to the negative 7, which is ln, and then multiply 4 times 3 to 12e, and then you use Power rule, which is adding the exponents. So ln 12 e to the 0 power, but 0 power equal to 1, so you got just ln 12. For the sum of the log, so you can multiply 4x times 2x, so you got log of 8x squared. And that's all. There's nothing you can do about this. And then quotient rule, so base of 2, x of 4 over x, which is same as base 2 of x cubed, because x 4x it cancels out. Write the expression as a logarithmic, a single expression. So I have a log, and then 6 and 3 are the positive logs, so you gotta multiply together. And then 9 with a negative, so you need to put the 9 on the bottom. So which is log of 18 over 9, which is same as log of 2. Okay, you wanna make a single expression, we have to put the factor as a power. So we need to put the ln x to 4, ln y to the 1/3, and then ln z to the half power. And then I can put that as ln of fractions, and then positive ln term come out the top, negative ln term goes the bottom, and z is also the positive. This is always come with a positive, so I need to put the z to the half on the top. And then you can go further for the, instead of the rational root, the rational power, you can use the root. So cube root of y. Okay, yeah, so this is it. All right, next page. All right, now, and then letter C. Same thing too. You need to put the x power for x6, and then this is a log of 5 of 4x minus, I can say log of 5, and z is a power of the 3 over 2. And then I can put as log of 5 and the fraction. So the first x to 6 is a positive log, so I need to put the power x to 6 on the top. Second one is a negative log, so 4x goes the bottom. And then third one also is a negative, so z to the 3 over 2 goes on the bottom. And then cancellation, 1x cancel with the fifth, so I got log of 5 with a x to fifth, still you have a 4. And then you can put that as square root of z cubed. And also you can go further as x to fifth over 4, and then g cubed come out as z square root of z. And then I said this is it. Okay, and then we also can use a base formula. It is actually the calculator that there's no other base you can use except the 10 and the e. So in this time, in order to calculate the log of base of 6 and then the 33. So if you have a calculator, I think the CASIA calculator has a space that you can type the C as a base, but other calculator not. So what you need to do is you can choose any of the base. So you can choose the base of B if you want, but I love the base of 10, so I can just put the log of x over log of A. Or you can just ln x over ln a. So you can use either one to get the same answer. So first one, I want to use the log of base 10 of 33 on the top, and then 6 on the bottom. And then, or you can just say ln 33 over ln 6. And then just use a calculator to find the answer. So ln 33 divided by ln 6, I got that as 1.95. On the second one, first of all, I'm just going to change it as base 2 of 6 over 150. And then 6 over 150 reduced as 1 over 25. And then you can just change as log of base of 10 as 1 over 25 over 2. Or you can say ln 1 over 25 over, oh, sorry, that's not true. That's not, what am I doing here? No, that's not true. Sorry. So this is going to be log of 1 over 25 over log of 2. And the ln 1 over 25 over ln 2. So either ways you can get the same answer. So log of 1 over 25 divided by log of 2. I have a negative 4.64. Okay, all right. I think that's all. Thank you for listening.